Oops. Minimize. Why is that not working? There we go. Okay, let's start with the first one, absolute value. You should be able to do this stuff flawlessly. 6 minus 11. Sorry, 5 minus 11. What is it? Negative 6. Okay, then what do you do next? Well, it's the absolute value of that, so it's 6 plus 6, which is 12. Okay. The reason these are simple, right, because you have to get the rules of absolute value in here. Okay, what do you do next year on this one? What's the absolute value of 7? 7. What's 3 minus 2? 1. No, it's positive 1. So negative 2 minus 7 plus 1. What do you do next? Yeah, so what do you do? What do you get? This is negative 9 plus this is negative 8. There we go. Okay. These shouldn't take long, guys. Okay, 24. Okay, so 24 over top of the absolute value. What is 12 divided by negative 2? Negative 6. Is that correct? Negative 6. What's the absolute value of negative 6? 6, but then you times it by negative and it becomes negative. So that's 24 over negative 6, which is negative 4. You're supposed to have all this done. Okay. You're kidding, right? This is, what test are we coming up to? Chapter 8. And every single time, have we done the review right away that you have to have it done on the day of the test review? Nobody told that you had to have this done? You're kidding, right?
Because the test is on Tuesday. We always do the game before the test. Well, see, no one told me that.
When you're not here, like,
I don't listen. I do my work.
Okay, absolute value of 2. Okay, so 2 times the absolute value of negative 3. And then when you take it out, it becomes negative. So it's still times negative 3, right? I'll put that in brackets just so I don't forget. Times negative 2. Okay, 2 times negative 3. Negative 6 times negative 2. Positive 2. These would be like multiple choice questions on the test, right? They're going to be a little bit harder. Yeah, they're going to be more like, I could give you something like, you know, the division one with this on the bottom. Yeah, big deal. I mean, you can handle it.
Why they're going to be harder in the test? Why?
Okay. Now, consider the function 2x squared minus 16x plus 29. What form is that in? Standard form. We want to express it in which form? Uh-oh. What's this called? Completing the square. Remember this stuff? Okay. Now, the reason you complete the square is because both pieces of information give you something useful. If it's in standard form, it often gives you the y-intercept. It's whatever the tail end is. If it's in vertex form, it gives you the vertex. You can tell whether it's positive or negative, so it opens up or down. Okay, so let's complete the square on this. This should be easy for you. Now, what we're going to do, we're completing the square with an absolute value. When we graph this, the only thing that's going to change is you're going to graph it like normal, the quadratic, but then when you deal with the absolute value, it's going to kick it from 3 and 4 into 1 and 2, right? Is that correct? Okay, so can we just complete the square like it was a normal quadratic? Yeah, because we know what we're going to do at the end. Okay, so y equals 2x squared minus 16x, and I'm going to move the 29 over here, right? Because basically what we're going to do is we're going to deal with this part first, right? We're going to have some stuff there and there. Is that correct? Now, you have to realize something. What can you take out? You can take out a 2. Now, because I split it, you're not going to take it out of the 29 there, are you? Sorry, what was that? That was a plus 29, right? I should have written that in. You're not going to take it out of that. So y equals 2 comes out. So you're left with x squared minus 8x, right? This one plus 29, this one. Right? Biggest mistake you guys have made in the past is you take the 2 out of the front end, but you forget to take it out of the middle, right? That's a common one. Okay. What number are we going to take and divide by 2? Negative 8. So we're going to take negative 8, we're going to divide it by 2, and then what are we going to do with it? We're going to square it. So we end up with negative 4 squared, which is plus 16. Okay. Ooh. What happened there? Hang on. plus 16. Okay, so there we go. I'm going to add 16 here. Normally, because we're on the same side of the equation, we would normally do what out here? Subtract 16. But careful, it gets out of the confines of the brackets there and gets attacked by a rabid 2. So instead of subtracting 16, we're going to subtract 32. Do you remember this now? Okay. Now let's just make our thing here. Okay. What is it? X minus 4 squared. What's 29 minus 32? Minus 3. Well, that tells us right away what the vertex is. What's the vertex? 4, comma, negative 3. Why is it positive 4? Because it's the number that you plug in that to make it 0, right? So it's 4, comma, negative 3. What does the 2 do to this thing, the 2 out the front? Does it make it narrow or does it make it wide? It makes it narrow. Positive 2, so does it open up or does it open down? It opens up. Hey, what is the y-intercept? 29. Oh boy, that's a problem. It's way off the graph, isn't it? Okay. What else do we need to know? X-intercepts. Now, here's the deal with this one. This one doesn't work out really nicely for x-intercepts. If I give you one on the test, is it going to be a really nice one? Are you going to be able to find the x-intercepts? How would you normally, if I did this, how would you normally find the x-intercepts? You would take standard form and do what to it? Factor it into 2 of them, right? If it's not a nice one, how are you going to have to do it? Quadratic formula, right? This one actually is quadratic formula because the y-intercepts, right? Let's write that down, just so we're clear on that, right? To find, I don't want to actually do this because it takes quite a bit of time, and the one you're going to get on the test will probably be just really nice, like I said. So to find x-intercepts, right? X-intercepts, you either factor, right? That's the easy way. If not, then use quadratic formula. Right. Basically what you're going to get test-wise is I'm going to give you one of these, right? I'm going to ask you to graph the sucker, right? So the key points you're going to have to know are like x-intercepts, y-intercepts, vertex, right? That's the key thing. Does it matter to me how you're really going to accomplish that when you get to the end? No. I mean, if you really wanted to, could you find the vertex with the negative b over 2a? Remember, little x equals negative b over 2a? Yeah, you can do that if you want. It doesn't make any difference to me. So I'm going to give you in this case, because we're not going to factor it out, I'm going to give you the 2 x-intercepts, just so we know it's negative. Oh, sorry, it's not negative. 2.8, comma 0. 2.8, comma 0 is one of them, and 5.2, comma 0, right? I'm just giving you those, right, because we're not going to waste the time doing this.
So it's like those were given.
Those would be given, but on a test you would be able to factor them quite easily, right? Like I'll give you a nice one, something to factor. So let's put this on the graph. Now you always graph the original and then deal with the absolute value, right? It was the same with the reciprocal, right? You graph the original and then deal with the reciprocal. Okay, so let's graph the points here. What was our vertex? 4, negative 3 right there. The 2 x-intercepts are like 2.8 and 5.2. What is this thing? Does it open up? What's the y-intercept if we actually could see it? We can't. It's way off the graph, right? So let's just sketch this out. We're just sketching this so we have this. Right here. Right there. There we go. Beautiful. Okay. Now, that is of the original equation. What does the absolute value look like? What do we do? No, it does not find the reciprocal. Everything in the fourth quadrant goes into the first quadrant, right? So everything down here, this bottom part of this loop, where does it go? It goes into the top, right? It goes up here, like this. Oh, sorry, hang on. Let's actually be clear about it. Now, here's an interesting thing. Let me just graph that again. This board goes so out of alignment. Was it 5.2? This one was 4 comma negative 3, so what is it now? 4 comma positive 3. Oh, that's kind of useful. So it actually looks like that, right? It goes through that point. So this whole bottom piece is now gone, right? So this point here is 4 comma 3, right? We can actually label these as 5.2 comma 0. The x-intercepts 5.2 comma 0, and what was this? 2.8 comma 0. And I'll give you those, or you factor them. Right? Now, more important to this question is, and this is kind of where I'm getting at, is the domain and range, because you're still kind of struggling with these also, right?
No.
The domain is really quite easy. Domain is the x value, right?
It is.
So look, that's it. Has it been that pretty much like 99% of the time? I don't think it's really changed all that much. So the domain is, we could do it this way, negative infinity to positive infinity. Or how do you write it the other way? X is an element of R, is that correct? It's all real numbers, basically. It means every number that you could ever think of.
If we can tell us to find domain and range, so we can find out the original one or the one plotted out.
No, because we're plotting. This question asks, consider the function, express the function. We're talking about the absolute value. The only reason we did the original is so we could have something to graph it. We were considering the absolute value.
If we did the first one.
It doesn't matter. I give you both because you're never going to know when you hit university or college what your prof is going to ask for. No, you can't. You do what they want.
Why would they tell you to do it either way?
Why would they care? Like, you just draw the graph.
Guys, if you get that in university, your prof is either going to give you that way or that way. You have to understand both because you don't know which way they're going to give you.
Did you care?
Okay, what's the range? Now careful with this one. Range is a little bit trickier. No, the range is the y value. What is the lowest y value? 0. No, it doesn't matter. What is the lowest y value right there? 0. So that hump there, right, is 4 comma 3. Who cares about that? What's the lowest y value? And it goes on to where?
Forever.
Positive infinity. Okay. So our range in this case is square bracket, because it includes that point, to positive infinity. Or another way of writing it for y value, another way to write it for y values is what? Y is what? Greater than or equal to 0, and y is an element of R, because every number past that is an answer. No, the domain is all the x values. It goes on forever that direction. You have this graph wrong. It goes on forever that direction and that direction. So it's still going all the way to negative infinity and positive infinity. The y is 0. What? Okay. So let's go to the next question. Barry! Good old Barry! Barry went on a diet to lose weight. During January, he lost 15 pounds. Okay.
1 month.
That's a lot of pounds.
Really a lot.
Then in February, he lost 8 pounds more. During March, he gained some back. What was the final amount of weight that Barry lost and gained during this period? It is. But do we care about the positives and the negatives in this case? Or do we want just the total value that he gained and lost? The total value that he gained and lost. Okay. So, what did he do during January? He what? Minus 15, is that correct? What did he do during February? Another 8. What did he do during March? Plus 6. What we want to know, guys, is we want to know the total value, like overall, that he gained or lost. Just the total amount.
Add them together. Subtract them together.
No, but if you add them together, you're going to have a negative and a negative. That'll give you what he ended up at.
Yeah.
But what I want to know is I want the total amount that he gained or lost, like the overall amount.
I don't understand.
The what? You have to do the absolute value of each one, because what I want to know is what was his overall gain and loss. So you could say in total, right, everything. It's, for instance, we do this at the stock market, right? The stocks go up and down in price, and we can calculate what their movement was for that whole day, which includes all the positives and the negatives, right? You just make the absolute value. So what's the absolute value of 15, or negative 15? Absolute value of negative 8? Absolute value of positive 6? Add them together, 15 and 8 is 23, plus 6 is 29. So what was the total amount of weight the berry lost, and gained? So 29 pounds in total, right? Some of it was losses, some of it was gains. What? It is a trick question in some ways. You actually have to look at what the question's saying. Yeah. But most of you, I guarantee you, if you had done it the way that you thought about it, would have most of you got it wrong? If you had taken negative 15 plus negative 8 plus 6, I know. That's why you have to read the question. You have to be really close about this. Be careful about this thing. Okay, next question. Next question. Leave them if you're bored.
I'm leaving out of the review because I have to go.
Okay, the velocity of the object is given by the formula v equals 25t minus 80, where t is expressed in seconds, right? So t, 1 second, 2 seconds, 3 seconds, 10 seconds, whatever it was. And the velocity is expressed in feet per second, right? So a velocity of 10 would be 10 feet per second. Okay? Find the times when the magnitude of the velocity is equal to 60 feet per second. It's really quite simple. Do they tell us what the velocity is? So it's 60 equals 25t minus 80. Okay. Now here's the thing. There are times, when you think about quadratics, right? Quadratic is a nice little parabola, right? Think about rockets. Rocket's going up in the air, goes up in the air, and then it comes down. Is there a time when it reaches 100 feet going up? Is there a time when it reaches 100 feet coming down? So the thing is here, with the time, think about this for a minute. This 25 minus t, or this 25 times t, this number could be a really, really big number, right? A really, really big number minus 80 would give you 60, is that correct? But could this number also be small? A small number minus a big number will give you a negative. But what unit are we actually on? Absolute value. So when we're talking magnitude, we're always talking like a positive value. So we need to put some absolute value signs around this guy. Where are we going to put them? No, the 60 is always going to be 60. Could this number be positive or negative on the right? You'll see in a minute once we actually do this. Okay, so what we want is we want absolute values around this. Because this number could be positive, this number could be negative, depending on what seconds it is, right? If this number is really small at the front, it's going to be a negative. If this number is really big in the front, it's going to be a positive. Now, how do we solve this? We did this with absolute value. It's really quite easy if you remember correctly. No, yeah, it's kind of like the piecewise. Yeah, you're right. So what do? Make one positive and make the other one negative. Well, that was easy, right? Okay, so let's make one positive. So 60 equals 25t minus 80. There's one that's positive. What do we do with the 80? So we'll add it to the other side. What do you get? 140 equals 25t. How do you get rid of the 25? Divide. Okay, grab your calculator. Tell me what you get for t. So 5.6 seconds. So at 5.6 seconds, the magnitude is going to be 60 feet per second. Or so the velocity is going to be 60 feet per second. That's the positive way. That's super easy. The next one is the one that's always going to throw you. Basically, where the absolute values are, replace them with what? Brackets, and make the whole thing negative. Wow, that's tough. So 60, whoops. 60 equals negative 25t minus 80, just like that. So what do you do with the negative? Well, you can divide or you can distribute, it doesn't matter. So 60 equals negative 25t plus 80. Move the 80 over to the other side, what do you get? Negative 20 equals negative 25t. Negative divided by a negative is still a positive. Can time be negative? No, it's going to work out for you always. But so what do you get? 0.8 seconds. 0.8 seconds. So there's actually two times when the velocity could be 60 feet per second. You think about it, like I said with a rocket, right? There is some point when a rocket goes up in the air and comes down, there is a point when it's exactly the same height. One's earlier, one's later, yeah? Because, oh, okay. But some of you know how to set up that formula with the absolute values. No, is there one of these on the test? Yes.
Don't put the negative in front of the 60.
No, because it's always in front of where the absolute value is. Yeah. Well, okay, there's two ways of doing that. You could distribute the negative or divide both sides by negative 1 or times it by negative 1. Doesn't matter. You can do it however you want. Yeah, same answer will come up. Okay, question 5. There we go. You. It depends on if you understand it or not. Okay, well, so you have a lot of time to actually study for this. You have today, Saturday, Sunday, and Monday.
And Tuesday.
Yes, but that's what you have to balance, work and education. No, it's not. Guys, can I explain something to you? You seem to think work is very important at your age. It's not. Because education is one of the prime indicators of how much money you'll make later in life.
Yeah, but you have no job experience if your parents don't.
Yes, but if you go to university and become an engineer, the job experience of working at a fast food restaurant is sure not going to help you at an engineering firm.
Okay, well, how are you going to make money then?
But if you can't go to university,
Your parents will provide you with basic necessities.
no, they don't.
They provide you with a house.
Yes.
Do they provide you with food? Do they provide you with basic clothing? You may not like it, but do they provide you with basic clothing? Yeah, nice try, guys. Okay, solve the equation and verify the solution. Now, this is what you're going to see on the test, where you have to solve and then verify. And I want to see that. Okay, how do we solve this? It's easy, we just did one. Make one positive and then make one negative. Okay, so here we go. Sorry, what? We'll get to that yet. Okay, what's the first one? So x squared minus 1 equals x. There it is. That's the first one. How do we solve this one? No, look at on the other side of the equation. No. Sorry, what? Yeah, make it all equal to 0. Okay. So make it all equal to 0. So it's x squared minus x minus 1 equals 0. Then what do? Try to factor. Guess what? Is this going to factor? No dice. So what are you going to have to use? Am I putting one of these on the test? Yes. You have to know how to do quadratic formula. It does not go away. It's like a bad cold. It just keeps coming back. Well, food poisoning goes away. Okay, so here it is here. There's our quadratic. What should we do first? Label ABC. Then write down the equation. Then find the answer. Okay, so here. Well, what's A? 1. What's B? Negative 1. What's C? Okay. So write down the quadratic equation. X equals negative B plus or minus B squared minus 4AC all over 2A. Okay. Someone let you know. X equals, what's negative B, negative 1? What is it? Positive 1. Plus or minus? Negative 1 squared minus 4, what's A? 1 1, what's C? Negative 1. All over 2 times 1. See if you can get the math right on this next part. Yeah. Now, you can do it if it's negative, but you'll make more mistakes. So what I would do is if you ever ended up with a standard one and your A is negative, just run through a negative through it, right? Basically, what do you do with all the signs? Just change them, yeah. Do that. It'll make it way easier. You can. It will work 100% of the time, but sometimes there's easier ways of doing it, right? For instance, GTF, factoring, anything like that. You always try those first. Okay, so you get 1 plus or minus root 5 over what? 2. 1 plus or minus root of 5 over 2. You should get that, right? You guys have done enough quadratic equations. So do the other one. How do you do the other one?
I can put a negative.
Yes, you do. Take it and get rid of the absolute values, put brackets around it, and make it negative. We did this. We just did this on the last question. Take this, put brackets around it, and make it negative. That's all we do, right?
Here, divide the negative, or
I would divide out a negative because you're going to have to get rid of it anyways. Or just move it all to the other side.
I thought the next divide.
Yeah, you can. Okay, so you want to divide by negative. You end up with x squared minus 1 equals negative x. That's the only thing that changes, right? But you still have to bring it over to the other side anyways, right? So x squared minus x minus 1 equals 0. Thank you, plus x. Yeah, if I can do it correctly, that would help. It's good when I can't even do it right, eh? I was going to say, because we ended up with the exact same ones as we did before. That's not right. What's A? What's B? What's C? Plug it into the quadratic formula.
The exact same thing except for...
Oh, see, now you're actually thinking, right? Because you've done the work once, you can actually figure out that there's less work in the next step.
The exact same one, negative 1 plus or minus squared.
What's wrong? Oh, on the other side? Sorry. That part? It's kind of cool, actually. It's the same pattern. The only difference is instead of 1 plus or minus root of 5 over 2, it's negative 1 plus or minus root of 5 over 2. Right? As you get better with this stuff and you see patterns, you can actually start saving yourself some time. What? No, you wouldn't have to. Right? If you understood that concept right away, could you write down the final answer right at the end?
That's weird because we're used to like writing down all the can't write down the answer.
But in this case, you've already done all the work, right? Yes. Okay. So let's write that. Here, we need A, B, and C, don't we? A is 1, B is 1, C is negative 1. The only difference is, what was different? The B, right? So write down the formula. X equals negative B plus or minus B squared minus 4AC all over 2A. Let's fill in what we know. Negative 1 plus or minus 1 squared minus 4 times 1 times negative 1 all over 2 times 1. Do you see what Justin was talking about? The only difference is what?
Negative 1.
The negative 1, right? The 1 and the negative 1. Sorry? What's dumb about it? It's actually kind of nice. Yeah. But we're not done though, right? Basically what we have on the board there is how many solutions? 4 solutions, right? 1 plus root of 5 over 2, 1 minus root of 5 over 2, right? And then with a negative 1 in front. So what we need to do is we need to verify. So it could be a possibility of 4 answers, right? Could be all 4 answers, could be 3, could be 2, could be 1, could be none. Okay, now let's verify. So basically when you're verifying, right, you're trying to decide if the left side equals the right side of the original equation, right? So let's go. Let's go back up to the original. I bet you we can do this. What I want to know is, I just want to make my life a little bit easier, because 1 plus root of 5 over 2 really doesn't mean anything to me, because it's not really a number, right? Could you give me an estimate of what that number actually is? It's 1.1? 1.6, okay. So this is approximately, oops, it's either approximately 1.6 or, what's the other one? Negative 0.6, or approximately negative 0.6, right? Okay, let's try this then. Let's go back up. Sorry, what are we doing here? So we're trying to get approximately 1.6. So 1 plus root of 5 over 2. So square that. What's 1.6 squared? What's 1.6 squared? We'll just do it. So 2.6 approximately, right? Okay. What's 2.6 minus 1? 1.6. Does 1.6 equal 1.6?
Yes.
Let's try that again. I want to make sure you're getting this, right? Because I don't want to do all the math that goes with it, because it's just a pain in the butt. Right? We're actually verifying this mentally. So we said, hang on, look back here. This number right here, 1 plus root of 5 over 2 is approximately 1.6. Okay, isn't that what we said? So go back to the original. So 1.6 squared is, what did we say it was? 2.6 approximately. 2.6 minus 1 is 1.6. Does it equal 1.6? So what does that tell us about 1 plus root of 5 over 2? So that is one of them. So 1 plus root of 5 over 2 is one of our solutions. Is that correct? Let's try the other one. Negative 0.6. So try this one. Hang on. What is negative 0.6 squared? What is it? Positive 0.36, right? Because it's negative. So positive 0.36. Minus 1? Negative what? Is that what it is? Is it exactly the same or no? Okay. I was waiting for somebody to kick it. Took you guys a while on that one. I know. I was waiting to see if somebody would get it. You're the only one that got it. Wow. It's impressive. Okay. No, I'm trying to get you to think. And sometimes by asking you stuff or doing stuff, I get you to actually think about it. Now think about when we actually verify stuff. What is the key to verification? You got to put it in where? The original. Where did I put that one into? Not the original. I put it into the left-hand side one, didn't I? Oh, is that a bad thing? Now, guys, do I see that a lot? Yeah, I see that tons of times, right? People just put it back into that one. Because it's on the left-hand side, you're putting it into that one. And then you do the one on the right-hand side, you put it into that one. It looks the same, but you got to put it back into the original because the original has the absolute values. Okay, now stop and think about this for a minute. This is where your brain power actually starts kicking in. Yeah, we're good. Nice. Now look. Oh. What's the answer here? This approximately? Negative 0.6. Now go back up to the original. Could you ever have an absolute value equal a negative?
No.
Oh. Do you even have to do the math? No. So you know right away, oops, this one's a no. Right, because of the negative. Okay. What are these two approximately? Right, because the only difference is the negative in the front. So it's going to be 0.6 positive, and the other one's going to be negative 1.6. Okay, what does that tell you right away? This one here is going to be a no. What do you think about the top one? It's going to be a yes. Could you check it? Do you want to check it? We can. Yeah, we did, didn't we? 0.6 squared is 3, what did we say it was? 0.36, right? 0.36 minus 1 is going to be a negative, but then when you take the absolute value of it, it become a positive, right? Or whatever it was. Okay, so this one's going to be a yes. Okay. This is where you start actually moving beyond basic math and move into thinking about what you're actually doing. Okay, we still need to write our solutions. What are our solutions? So our solutions, what was it? 1 plus root of 5 over 2 and negative 1 minus root of 5 over 2, right? It was the second part, wasn't it? No, the first one. Sorry. Plus, sorry. Okay. Yeah? No? What do you think? That's a big question, isn't it? But you can handle the parts. Now, if you didn't see the basic things that are about negatives, could you actually do the math? Yeah, you could. You spend a lot of time doing it, but that would be a waste.
Verify your solutions. You have to do that on paper.
Yeah, but if you say verify and you do that, what could you put for your verification? Why? Yeah, but you can't be negative. That's what you would put. Well, because there's a pattern there, that's a negative. You put no. Those ones you can actually do your basic calculations. You can do it on the paper. If you want to do approximations, that works too. Because in this question, it's a really simple kind of basic question. Okay, now here we go. This is the big one. If you notice, I gave you 2 pages. Is it going to be this difficult on the test, this one? No, because it would take you too long. Like we have, 25 minutes? It's probably going to take us 15 minutes to do this question because of all the explanations. Okay. Let's look at the question. What does that look like first? Can you? I don't know. It's quadratic though, isn't it? We're gonna sketch this graph, and then we're gonna sketch the reciprocal. Okay. How do we sketch this quadratic? What do you need to know? X-intercept. That's useful to know. What else do you need to know? Y-intercept. I think I know what the y-intercept just by looking at that is. What is the y-intercept? Negative 8. X-intercepts, y-intercepts. What else? Vertex. Could you complete the square if you wanted to? Could you also use negative b over 2a? Hey, we're not completing the square. It takes too long. Okay, let's do this. So what's the y-intercept? 0, comma. Let me write that again. Sorry. Oh, that's right. Yeah, 0, comma. I just wrote it backwards. 0, comma, negative 8. Okay. What? Well, it's positive, so it opens what? Up, so it's a valley. Okay. How do you find the vertex? X equals negative b over 2a. What's negative b? Yes. What's negative b? Negative 2 makes it negative, so it becomes what? Positive 2, what's a? 1, so 2 over 2, so what's the x value? 1. Positive 1. So what's the y value that goes with that? Plug it in. What's 1 squared? Minus 2. 1 minus 2. Negative 1 minus 8. Negative 9. So the y value, so the vertex is 1, comma, negative 9. This is the vertex. X-intercept.
Wait, should you mark it down first?
Does it work? Does it work? So y equals, let's factor this to see if we can get the x-intercept. Oh, sorry, we're going to set it equal to 0, right? I guess I should write that in there. The negative in front of 8 means the signs are different. 2 factors of 8 that when subtracted give you 2. 2 and 4, right? Okay, so x, and we want the 2 to be the, and so 4 there and plus 2. So what are my x-intercepts? So 4, comma, 0 and negative 2, comma, 0, right? Those are my x-intercepts. Wow, actually, this one works out quite nice, doesn't it? So far. Wait till we get to the invariant points. Invariant points are actually quite easy once you look at it. The invariant. When we get to it, I'll tell you. Okay. Graph this thing. That would be nice. Vertex, 1 comma negative 9. Y-intercept was, what was it, negative 8? 4 and, whoa, my graph is so off, or my board is so off. And negative 2. Okay. Let's try to sketch this in properly. Okay. So there is our quadratic. Now, did we spend like a whole 2 units on this stuff? Yeah, we did. Right, in different forms of whatever it was. But we want a graph is, and now, would you label all those points on your graph?
No.
Of course you would. It's useful, because if you're going to give me this work. Now, what we want to graph is we want to graph the reciprocal, right? So the reciprocal, when we graph a quadratic, it only is going to look one of 2 ways, right? What are the 2 ways it's going to look? Do you remember? I'll just do this on the side here. Don't write this down, but you should remember this. Yeah, so it's going to be like this. It's either going to be, you're going to have your asymptotes there. It's either going to be this, this, and this, right? Or it's going to be asymptotes again. It's going to be this, this, or this. Is that correct? It's going to be one of those 2, right? We know that. We learned that already. Okay. Let's get rid of this. We don't want this on the screen here. Okay. Now, I guess kind of the key thing is when we look at our graph here, wouldn't it be nice to know what the asymptotes are? Now, the interesting thing is, do we know what the x-intercepts are? Then those become the what? Which ones? The vertical asymptotes. Where's the horizontal? At the x-axis. Well, that's really not that hard. Okay, so what should you draw in? Asymptotes. Now I'm going to do them in a dotted line. I'm going to put one at, I'll line these up in a sec, guys. One at 2, one at 4, and I'm going to put this baby in right there also. That one there. That one there. There it is. Okay, that's not bad. So it's either going to be, right, top and the bottom middle, or the bottom and the top middle. Well, it's really quite easy when you look at this. No, the x-intercepts don't tell us anything. The key to this thing, and the key to thinking about this, is the y-intercept. Where is the y-intercept? It's 0, comma, negative 8. So if we do the reciprocal, we don't do the reciprocal of the 0, we do the reciprocal of the negative 8. What is the reciprocal of negative 8? No, that is not the reciprocal. That's the opposite. It's negative 1/8. So which quadrant, where is that? It's in the, where is it? It's in the bottom. So this little guy here, this one here, is going to flip up to here. Is that correct? The y-intercept is just going to flip up to negative 8. So is that where our graph's going to be? So if it's in that bottom piece, where are the other 2? In the top right and the top left. What? Just the y-intercept. No, because the vertex is 1, comma, negative 9. The only reason we can flip the other one is because of the 0 in front of it. The 0, comma, negative 8.
I'm still confused why you would...
You only flip the y-intercept. Just write it down. Just what?
What do you flip it to?
Negative 1/8. So what you're going to flip in this one, because the y-intercept, right, this is the one to change here, negative 1/8. The reason you don't do the other one is, whoa, jeez, that board is off. The reason you don't do the other one is because there's a 1 there, right? The reason we can do it with the other one is because there's a 0 in front. There's nothing to flip with that one. Okay. Now, but what else does this graph say? You'll see in a second. What else does this say? Okay. This is the math. This is the one that's going to throw you, right? This is the one that's going to throw you because this is the harder part when it comes to math. Now, but you kind of know the rules. Flip the page. This is where you're going to do all your work on the next page. Because it's going to take you an entire page. So we're going to plot the invariant points. Invariant Now, if you forget what invariant points is, you might want to write this down. Well, you tell me, what are invariant points? That's the easiest way to realize it. They're the points that are the same on the original graph and the reciprocal. That's it. They're exactly the same points.
Do that again?
Invariant points are the same points on the original graph and the reciprocal. They're exactly the same. Now, to do the math, what do we set y equal to? Yeah, no, not 0. We set y equal to plus or minus 1. You will often see it this way too. F of x equals plus or minus 1. Do they mean the same thing? Plus or minus 1. Just the rule. In university, in university you will actually do the proof. We're not doing it now. You just need to know that. It's a simple thing. You just set them to plus or minus 1. You don't need to know the proof. Just like you don't need to know how Pythagorean theorem works, you just do it. Right? You set it. Now you'll see it either way. You'll see either y plus or minus 1 or f of x plus or minus 1. Okay. Sorry, what? It's really quite a basic principle. It's the area of, it's the area of 3 squares, basically. Okay, so what we do is we set it to plus or minus 1. So let's do this one over here. So we're going to set, what was the equation? X squared minus 2x minus 8 equals 1. X squared minus 2x minus 8 equals negative 1. There it is. There's 2 of them. Both of these are ugly. Let me get down to them. Both of these are going to be quadratic. Yep. So let's do the math. Oh, stop. So what do we do here first? Move the 1. So x squared minus 2x. Move over the 1. Minus 9 equals 0. What's A? What's A? 1. What's B? What's C? Negative 9. Write down the quadratic form, you can do that. What's this one? X squared minus 2x. Guys, move the negative 1 over. Minus 7 equals 0. What's A? 1. What's B? What's B? Negative 2. What's C? Okay. Take a minute. Take a minute, guys, and do the quadratic formula. Let's see if you can get this part right.
It's not going to be like,
Now, what I'll give you on the test probably is if I give you one for invariant points, it'll be something that'll factorable. There is a quadratic formula question on the test, though. I'm putting one on there. No, it could be like that other one where that we had the x squared, which wasn't that bad. Basically, these invariant points are just to help you graph the equation. We already know what it looks like already, don't we?
Yeah.
We're just going to put the points on the graph. So once you figure out your 2 quadratic equations, or so your 2 points, turn them into approximations with decimals. It'll help us find them on the graph. I always have trouble finding them when they're in radical form. And I'll show you one last trick about the y-intercept of the reciprocal. That may clarify your answer or your question before, Justin.
What question?
The one you were asked about, why don't you flip the other one? I don't know if it'll clarify. Well, we'll see when I get to it. Was I staying at lunch today?
No. He wants to.
I'd like to go home. I've been home at lunch in a long time. What do you think of it?
Looks pretty good, actually. I like it. Yeah. I got it right away.
What? Underneath my desk.
How do you break them?
There's a whole stack underneath my desk.
How do you break them?
what color is your last?
Everything.
Your pink?
Probably.
Can we use them? For my vertical test?
Oh, you're doing the... Are you still making the pots?
Yeah, they're not sale.
I know, I bought 2.
Oh, did you?
How about the little purple one here? And then the gold one over there with all the sparkles on the Helen Keller thing on the front. Make another one and I'll buy it from you.
Ones that I have are like really girly.
And which point?
There's like one that has sparkles all.
That one has sparkles all over the top of it. I keep getting them all over me. I picked up the flower pot and I have sparkles all over me. No, you gotta glue them and then hairspray over the top. Then. Did you get your radicals yet?
Hold on.
Wait, where's the bottom of that? You need the bottom of this, guy. Oh, you did. Perfect.
But this is a negative though.
What? You can't take the value of a negative. You can't take the square root of a negative number. You know that. What did you get? Let's see. Yes and yes. Now, did you change them into? Give me those as decimals, though. Oh. Put them in decimals because it just helps you when you're actually trying to plot them on the graph. Oh, it's not 52. Something's wrong there. That's positive, right? Minus 4. So that's positive also. So that's 4 plus 36. 4 plus 36 is 40. That should be 40, not 52. I'm sorry. What you get it? Yeah, it's 40. You got it. Yes and yeah. So hopefully you have the same thing. Yeah, those are it. Yeah, 40. Yeah, 40. Yeah, it's perfect. Yeah, you got it right. Those are both wrong.
Yeah, no, they are.
Well, look. Where's your... Yeah, you have the wrong formula written down. Wow. You need b squared minus 4ac. Okay, so... No, just go to one or two decimal places, just so we can find them on the graph. So this one is x equals 2 plus or minus root of 40 over 2. I think that's what you all got, right? And this one is x equals 2 plus or minus root of 32 over 2. Is that correct? I think you all got that, right? That's basic quadratic formula. You should at least be able to pump that up, right? If you're making mistakes, it probably has to do with the b squared in there, right? Some of you forget that a negative times a negative. And or the minus 4ac, if it's a negative times a negative, it turns into a positive. Remember, those are the common mistakes. Yeah, you put it in brackets, because then you're always sure that you do it correctly on your calculator. Because if you put like negative 2 squared in your calculator, it's going to come out as negative 4, right? Put the negative 2 in brackets. Okay, so the approximate ones here are... Oops, that should be an approximation. Let me finish this. We're almost done here. Negative 4.2 or negative 2.2. Is that right? And this is approximately 3.8 or negative 1.8. Okay, now, in various points, we need some points to plot. So what was the value of y in this case? 1. So these two values of x here, right? Here's 4.2. That's not a 4.2. It would help if it was. 4.2. What's the y value? No, 1. Look, what is it? What's the y value? 1. Okay, that's 1 point. Or the other one is negative 2.2, comma 1. That's a set of points. They're exactly the same as the original as they are on the reciprocal. Okay? Why is it a 1? Because look, what's y equal to? What's this y going to be equal over here? Negative 1. So our 2 points, those are our x values. So 3.8, comma, negative 1, or negative 1.8, comma, negative 1. Right? We need points so we can graph them. Right? And that's what the invariant points are. They're the same on the original as they are on the reciprocal. Okay, let's plot these on the graph just to see what they look like. What? We got 5 minutes. That's all we need. Okay, here's our graph. So one of the points was 4.6, comma 1. Is that correct? I'll do this in blue just so we can see this on this graph. 4.6, 4.2 comma 1. Is that it right there? Oh my goodness. Look at how off that board is. Wow. Okay, so there it is there. So what's this graph going to look, what's this part going to look like? Is it going to come down here? Oh. Right, it's going to look like that. Oh boy. I really would like a new smart board. No, that's just not this. So that's 1 point. Does that make sense? Does it actually hit both the original and the new one? Yeah, it does. What was the other one? Negative 2.2 comma 1. So that's way over here. Oh, well, we knew that, right? Didn't we know that it has to be on both sides? Is that right? Yeah, it's on the top and this one over here. So draw this one in. Now, when you do this for me on a test, should you label these invariant points? Yeah, you do. Now, if you label them as approximations, like with the decimals, would I allow that? Sure, I don't care, right? Because you've done the work on the previous page. What about the other two? 3.8 and negative 1.2. So 3.8, right there. Oops. And negative 1 point there. Right? And there, look at that, that's our y-intercept. Now, Justin was asking before how we actually came up with that y-intercept. What's the reciprocal of this function? 1 over what? X squared minus 2x minus 8, right? What value of x is at the y-intercept? 0. What happens to this first piece? Plug in a 0. What happens to, what's 0 squared? Minus 0? What are you left with? Or as otherwise known as 1 over negative 8. So what's the y-intercept? Negative an 8. Didn't we know that already? Didn't we take the 8 and just do the reciprocal of it? Okay. So this point right here, we draw, oh, hopefully this graph doesn't screw it up. Comes through here, comes around, comes to this point, goes back down. So the black line is the original, the blue line is the reciprocal. It's not that bad. Is there a lot of steps? There is a ton of steps. That's what's going to confuse you. So hopefully, hey guys, when you do this for practice over the weekend and on Monday when I'm not here, should you go through it step by step? You have to, guys, and you have to be meticulous. Which, guys, don't pack up, please. You can't miss any steps when you do this, okay? Don't miss anything. Be very thorough, be very clear. Yeah.